Hi, my name's Leyden. I'm a PhD student at the University of Adelaide, and I'm currently doing my PhD looking at the geochemistry of coastal soils and how they change with sea level rise. So today I talked about one part of my specifically looking at geochemical changes in coastal soils with a short-term flush of seawater. So as sea levels rise, new environments will be inundated with seawater, such as lakes and streams. And we're interested in looking about once the seawater flushes into those environments for the first time, what will happen to the geochemistry of those soils. So we compared 5 freshwater sites in South Australia to 5 hypersaline sites and did a lab-based inundation experiment and looked at what happened. And what we found was that we had huge increases in dissolved iron and manganese in the freshwater soils post-inundation with seawater. We also had increases in things like cadmium and cobalt and copper and zinc, and dissolved metals across the board increased post-inundation in those freshwater sites. And that was in comparison to the hypersaline sites. And what we think is going on with this is that when we flush these soils with seawater, we induce a new redox state. So we go into a moderately reducing state. And what we think is happening is that we're dissolving manganese and iron oxides into free iron and iron 2. And with that comes an increase in other dissolved metals. We also think that cation exchange processes are occurring. In this environment, obviously you put seawater on, you're changing those different cations in solution, and they actually knock off a lot of those positively charged metals which hang on to the negatively charged soil particles. So those new cations coming in with the seawater compete with those metals for exchange sites and knock them off into solution. We also think that chlorocompensation is happening as well. So this was just some preliminary research. So next we're going to be looking at if those metal releases are sustained. So does it happen again and again, or is it just a once-off event? And what happens when those soils are saturated for longer periods of time? So what happens when we have seawater coming onto those environments for months and years at a time? How does that change the geochemistry? The last part of our research is actually looking at how we trace seawater inundation. So we've got a new method for looking at sulfur isotopes and using sulfur isotopes as a tracer for seawater inundation into new environments.